Good day, students. Welcome back again to our class. Today, I will be talking on practical lighting scheme. The outline of my presentation will be as follows. We will take first of all definition of illumination, then followed by laws of illumination, and then lumen lighting scheme. To start with, illumination refers to the provision of sufficient lighting either by natural sources, natural means like sun, or artificial light sources like electric bulb and electric bulb, so to say. So we are going to consider some terms that will be used in illumination. First of all, why is this important? Because you need to understand how flood lamps are created in the stadium, maybe how lights of street lights are, some calculations are done, maybe how the rooms lightings are done. Sometimes when you enter into a place, you discover that the lighting is very poor and you can have some inconvenience because of bad design. So the essence of studying illumination in electrical engineering is that tomorrow you may find yourself where you have to design either street light or lighting in a room, maybe in a library for instance, or lighting a hotel. So the few knowledge that you are going to get from this will help you to make some initial steps in designing illumination. So terms that will be useful for you in illumination. Number one is luminous flux. Luminous flux is the total quantity of light energy radiated from a luminous body or luminous, it is in form of a light wave. Its unit is lumen. The second one is luminous intensity, which is just the brightness of the light source, and its unit is candela. Third one is illumination or illuminance, so any of them. It is the amount of flux falling on a surface, so it is the flux per area. There are other terms like solid angle and several others, but these ones are the ones we need for this course. So, laws of illumination. We are going to consider some laws used in illumination. First one is inverse square law, which states that the illumination falling on the surface that to be illuminated is varies inversely with the square of the distance separating the light source and the surface. You can look at this diagram. This is the light source, this is the surface we want to illuminate, and then separated by distance d. So the luminance varies inversely with the distance, square of the distance separating the light source and the surface. The second one is the cosine law, which states that illumination varies directly with the cosine of angle between the normal to the surface, that is this angle normal to the surface, and the direction of the incident light. So the angle here, so E varies directly with the cosine E. If you combine this law and this law, and then you are going to get that E, which is the luminance, is equal to this I cosine theta, which is this angle upon this square. The I here is the luminous intensity, which is the brightness as we defined in the previous slide. Okay, these laws are applicable to point sources where there is no reflecting surface. That is, this law assumes that the source of light is just a point. Of course, the point light does not exist in reality. So this is applicable when the distance between the source and the surface is very far, that such that you can consider the light source as a point source. But in reality, point light does not exist. So these laws are useful for outdoor installations like street lights and garden light designs, but they are not good when you are talking about interior designs. Okay, for interior light design, what do we use? So let's talk about interior design. If you have is a room, for instance, you want to design, you will discover that as the interior light fittings produce illumination on the working plane or surface to be illuminated, there are also reflections from the fittings, walls, ceiling, and these reflections, they form additional secondary source of illumination. So you can see the kind of shadow, you can see a situation that you will not like. So which is why it is important to consider a good design of our interior in a room, or so to say. So practical lighting scheme usually by lumen method. So instead of using those two laws, we are looking at lumen method. Lumen method consider all the factors that affect light flux distribution, and it also consider the deterioration of the lighting unit's efficiency. So this one, you consider all the things that will obstruct the distribution of the light flux in the interior design, and also you take into account the efficiency of the lighting, the fittings and the light source itself, because it can deteriorate over time. So let's move on with this. Some factors considered in interior illumination are: number one, coefficient of utilization, or simply utilization factor. Not all the light energy given out reaches the surface due to losses. The losses here is, for instance, due to sealing, some of the light will be lost on the fittings, on the wall. So not all the lights, all the quantity of light given out reaches the surface at the end of the day. So there is a factor given to take into account of that, and it is usually 0.9. The second factor affecting illumination is the maintenance factor. Illumination will be impaired by dust, dirt, and aging of the fittings. So you, as your bulbs or this light source, as they attract dirt, or as they age, or as dust get to them, they can obstruct the distribution of light flux. And then this kind of maintenance, because from time to time you need to clean your bulb, clean your light source. So there is always a factor considered to take into account of this, and it's usually 0.8. But it can be less if the atmosphere is dirty and dusty. For instance, if you are working in a place where you are producing wood or maybe chemicals, the place will be dusty and the place will not be clear. So you can reduce the factor, but in practice 0.8 is good. And the last one, this is not the only one, but like I say, we'll limit everything because of the time we have. The last one, which is practical, is space to height ratio. The height at which you mount the fitting is very, very important, because if the fitting is in the line of vision, let's say it is close to the eye, it will cause glare. Glare is a phenomenon whereby light goes directly into the eye of someone that you don't really see clearly. Example, when there's an oncoming vehicle towards you, see the light will flash on your eyes and you'll be confused. So this kind of thing can be avoided if you bring the fitting so close, so down, you can create this kind of ugly situation. And if it is too high, the lamping and maintenance become difficult, because no lamp is forever. When you want to change it, it becomes a problem, or you want to clean the dust, it becomes a problem if it is too high. So how can we calculate some things to help us design in interior illumination? So let's look at expressions for illumination. First one here, which is, I think that's all we need, is the total lumen. Remember that lumen is the unit of the light flux itself. So the lumen, total lumen here, is the illumination, which is also lux or illuminance, multiplied by the area of working plane, which is a meter square, divided by maintenance factor, and then coefficient of utilization. You can see how all those factors are put together in equation. So if you make this illumination subject to a formula, which is E, so it becomes the total lumen multiplied by maintenance factor MF multiplied by coefficient of utilization CU divided by the area. So this formula is very critical and we're going to use it. Let's see how we use it. Example 1. Let's consider that a shop is 15 meter long, 9 meter wide, and 3 meter high. To the trusses, of course, trusses are those woods you see on the ceiling, before the ceiling, especially in the workshop. So will be illuminated at the level of 200 lux. So the level of illumination required here is 200 lux. The utilization and the maintenance factors are 0.9 and 0.8 respectively. The question is calculate number A, total lumen required, number B, total power assuming lamp efficiency of 13 lumen per watt. Okay. C, make a scale layout of the shop and mark out the lighting positions assuming a spacing height ratio of 1. Then the last one is determine the power required for each bulb. So this is not a very difficult one. We go back to our equation. So the solution, required lumen is the illumination multiplied by the area divided by maintenance factor and coefficient of utilization. So if you slot in all the figures, you are going to get 37,500 lumen. Okay, since the efficiency of the lighting is 13 lumen per watt, so and we have 37,500 lumen, so it means that you can get the total power, which is the lumen divided by that 13 lumen per watt. That will give us 2,885 watt in total. Okay, now we want to talk about design it. So we want to check the layout. Before you check the layout, you have to look at how the bulbs are spaced, and that's how we invoke the space to height ratio. So the spacing to height ratio in the equation is 1, which implies that the spacing is equal to height. And they told us in the description that the height is 3 meters. So it means that the spacing is 3 meters. So the lamp will be separated from one another by 3 meters. So let's try to sketch the lighting point here with this information. Okay, so I have the total length is 15 meters and the width is 9 meters, and I'm going to space them 3 meters. So between this bulb and this bulb, 3 meters, 3 meters, 3 meters, 3 meters. You will see that the remaining 3 meters will be divided into 2, which is 1.5 by this side and then 1.5 by this side. The same way between this and this 3 meters, this and this 3 meters. So the remaining will be 1.5 here, 1.5 here. So by doing spacing it by 3 meters, it means you are going to have 15 lamps in all. That's interesting. So now if you have 15 lamps in all, the last question is what is the power of each bulb? Then we can say that since we know the total power and we now know the number of bulbs, we can divide the total power by the number of bulbs to know the power of each bulb, and that will give us 192.3. Of course, you don't have that wattage in the market, so you can approximate it to 200 watts. So you are going to fix 200 watts everywhere, and then you get approximately 200 lux required by this design. So that's how we use that formula. So let's take another example. Example 2, a small assembly workspace of 25 meter by 15 requires 150 lux general lighting at bench level. The following options are suggested. Number 1, tungsten filament light rated at 150 watts, provide 13 lumen per watt. Option B, fluorescent bulbs rated at 80 watts, which provide 35 lumen per watt. The question now is, assuming that the lamp maintenance factor in each scenario is 0.8 and the room utilization coefficient is 0.5. So this room must be either a dirty room or very unclear room. So calculate the number of bulbs required for each option. We are going to use the same formula. Solution, required lumen, we start with this always, is the area, the illumination multiplied by the area divided by the maintenance factor and the coefficient of utilization. So the required lux is 150, so multiply it by area, which is 25 times 15, and then you divide it by all the factors. You arrive at 140,625 lumen. Okay, that's the total lumen we have. Then for option A, so total power will now be, since the efficiency of the first bulb is 13 lumen per watt, so per first option, so it means that the total power for that will be dividing the lumen by 13, which is going to give us 10,817.3 watts. Then we're going to now, to find the number of lamps for that option, we're going to divide it by the power of each lamp. That will give us 72.12. This is a number, so this can be, you have to round it up to something. So that will say 73 bulbs or 72 lamps. And for the second one, option, which is option B, so the efficiency is 35 lumen per watt. So if you divide the total lumen by that, you are going to get 4,017.86 watts. Then since the power of each lamp in that option is 80, we divide that total power by 80, and then we'll get 50.22 lamps, which is 51 lamps or 50 lamps to make it a round figure. So this is how we use the method, and that is called lumen method. Thank you for your attention.